Welcome back to the last section of the Ultimate Docker course. In this section, you're going to learn how to deploy your Dockerized applications. So we're going to take the same application we have been working with and put it in the cloud. We'll be talking about various deployment options, getting a virtual private server or VPS, using Docker Machine to provision hosts and connect with them, creating optimized production images, and of course, deploying the application and its updates. I think this is the most exciting part of this course because by the end of this section, our application will be live on the internet with its front end, back end, and database. So let's jump in and get started. To deploy our Dockerized applications, we have two options. We can deploy our application to a single host or a cluster, which means a group of servers. Now, as you might guess, deploying to a single host is really easy, but the problem with a single host deployment is that if our server goes offline, our application will not be accessible. And also, if our application grows rapidly and we get hundreds of thousands of users, a single server is not able to handle that load. That's why we use clusters. So with clusters, we get high availability and scalability. Now, to run clusters, we need special tools called orchestration tools. Docker has its own orchestration tool built into it called Docker Swarm, but as far as I know, it's not really that popular. I've done some research. Most people these days use another tool called Kubernetes, which is a Google product. Now, initially, I was planning to include Docker Swarm in this course, but after I did a survey and realized that only 5% of my audience really use Docker Swarm and everyone else uses Kubernetes, I thought that would be a waste of time and that would delay the production of this course. So I decided to drop Docker Swarm. Now, why didn't I include Kubernetes in this course? Because Kubernetes is fairly complex and really requires its own course or book. And quite frankly, it's not something that I know a lot about. So in this section, our focus will be on a single host deployment, which works for a lot of people. Don't assume that you need a cluster right from the get-go. You can always start simple, and if needed, you can transition to a cluster. So to deploy our application, we need a virtual private server or a VPS. Now, there are a ton of options to get a VPS. We have DigitalOcean, Google Cloud Platform, Microsoft Azure, Amazon Web Services, and of course, many, many more. These are the platforms that I personally have played with. Now, out of these, DigitalOcean is the simplest and most beginner-friendly one. And as we go down this list, we get more features, but at the cost of complexity. So I decided to choose DigitalOcean because I didn't want us to get distracted from Docker and go somewhere else. Now, all these platforms require you to provide a credit or a debit card to get a VPS. So to execute all the steps I'm going to show you in this section, you will need a debit or a credit card unless you already have access to a VPS. But if you don't let that discourage you. I still want you to watch this section so you have an understanding of the deployment process. So if you want to follow along with me, head over to digitalocean.com, create a new account, and then watch the next lesson. Once we have a server, we need to use a tool called Docker Machine to talk to the Docker engine on that server. So this way we can execute Docker commands in our terminal and our commands will be sent to the Docker engine on our server. So head over to github.com/docker/machine/releases. On this page, you can find the latest release. At the time of recording this lesson, it's version 0.16.2. Now down below, you can find the installation instructions for various platforms. It's super easy. We just have to copy this command and execute it in the terminal. So copy, paste it here, done. All right, Docker Machine is installed. Let's verify it. So Docker Machine --version. Perfect. So go ahead and install Docker Machine. When you're done, come back, watch the next lesson. All right, now we're going to use Docker Machine to create a virtual private server on DigitalOcean. So we type Docker Machine create. Now, this is going to be a long command, so we're going to split it onto multiple lines. Now, if you're on Linux, you can do this by typing a backslash at the end. If you're on Windows, you need to type a backtick, okay? And of course, this only works in PowerShell, not command prompt, okay? So backslash. Now on the second line, we type --driver Now, Docker Machine has drivers for different platforms. If you Google Docker Machine drivers, you'll find this page. So we have drivers for AWS, Microsoft Azure, DigitalOcean, and so on. Now, if you have a server in your own network and not in one of these platforms, you can set the driver to none. But here we're going to use DigitalOcean. Now, another backslash or backtick to go to the next line. Now, here we need to supply an option specific to DigitalOcean. So if you use AWS or another platform, your options are going to be different. So that option is double hyphens, DigitalOcean, hyphen, access, hyphen, token. So now we need to go to DigitalOcean and get an access token so Docker Machine can talk remotely with DigitalOcean. So here on DigitalOcean.com, on the left panel, we expand account and go to API. And of course, this user interface might change in the future. So if you cannot find it, just search for API on DigitalOcean. Okay. Now, here we can generate a personal access token. Let's go ahead. We're going to give this a name, Vidly, the name of our application, generate token. And here's the token. Now, this token is visible only once. So once we move away from this page and come back, we're not going to be able to see it. So copy this and keep it somewhere safe if you want to reuse it in the future. Okay. Now, back to the terminal window, we're going to pass that token here and then add a space and a backslash at the end so we can type the rest of the command. Now, at the time of recording this lesson, there is a problem on DigitalOcean. We cannot install the latest Docker engine on the server. We have to use an earlier version. Now, I'll put a link down below. If you open that link, you're going to see this page. This question was asked in December 21st, 2020. So it's fairly new. Now, down below, you can see the solution. So you have to add this extra option when creating a Docker machine. So with this, we can specify the engine install URL. So at this address, look, we're installing version 19 point whatever. Hopefully this issue will be fixed in the future and you don't have to add this option. So let's copy this line as well, including the backslash. And of course, if you're on Windows, you're going to replace that with a backtick. Now on the last line, we're going to give this server a name. We can call it Vidly or whatever. Now, Docker Machine is going to create a virtual machine by that name. And on that machine, it's going to install Docker. So then we'll be able to talk to that Docker engine remotely on our machine. Now, this is going to take a little while, so I'll be right back. All right, our server is ready. Now look at the output. Docker Machine was provisioning this with Ubuntu. This is the default image. Now, if you don't want to use Ubuntu, you can use a different image. So back to this page where we can see the list of drivers. Let's look at the DigitalOcean driver. Now down below, you can see all the available options. So we have an option for specifying the image to use. Okay. Now, once Ubuntu was installed, then Docker Machine tried to install Docker. So now we have Docker up and running on this machine and we can talk to it remotely. Also, if you go to the homepage of your account on DigitalOcean, you can see a new droplet called Vidly. A droplet on DigitalOcean means a server. Now over here, you can see the public IP address of the server. So we can copy this, open it in the browser. Currently, there is nothing there because we haven't deployed our application yet. So now that we have a server up and running, next I'm going to show you how to connect with this server. Let's see how we can connect to our server. First, we run Docker machine ls. With this, we can see all of our Docker machines. So currently we have a single machine called Vidly that is not active. We'll talk about that shortly. Here we can see the driver for this machine, which is DigitalOcean. Our machine is up and running. Here we can see the IP address of this machine. In the next column, which is called Swarm, let me resize the window so you can see. All right, so here's the Swarm column. This tells us if this machine is part of a swarm or not. A swarm, as I told you at the beginning of this section, represents a cluster. So this is a single host. It's not part of a cluster. In the next column, you can see the version of Docker engine running on this machine. And currently we have no errors. Great. Now, to connect to this machine, we're going to use SSH. SSH is short for Secure Shell, and it's a protocol for connecting with servers. So using SSH or Secure Shell, we can open a Secure Shell session with our server. Now, if you have worked with SSH before, you probably know that setting it up is a bit of pain. There are a number of steps you have to follow so you can connect to a server using SSH. Now, the beauty of Docker Machine is that it abstracts away all this complexity from us. So here we can simply type Docker Machine SSH and then type the name of our machine, which is Wheatley. Now, wait a sec. Okay, great. Now we're logged into our machine using SSH, and all of this was set up when we created this Docker machine. So as you can see, I'm logged in as the root user. We can look around. There's currently nothing in my home directory. Let's get out and run ls again. So here we can see the file system for Ubuntu. Our application is not deployed yet. That's why we don't have the app directory. So looks like our server is in a good shape. Next, we're going to talk about defining the production configuration. All right, this compose file we have created is great for development, but it's not ideal for production. For example, in our production environment, we don't need this volume mapping because we add this only for sharing our source code with our container. Similarly, we don't need this other container because we don't want to continuously run our tests in the production environment because this is going to slow down our server. It's going to unnecessarily use resources. So we're going to create a separate compose file for our production environment. So I'm going to copy this file, paste it, and then rename it to docker compose.prod.yaml. This is an arbitrary name. You can call it anything, but this is a convention that a lot of people follow. Now let's modify this file bit by bit. So for our web service, we're going to keep the build property, but I want to use a different port mapping. I don't want to use port 3000 on the host because I want to type the host name in the browser and bang, I want to see the application. So we want to map port 80 of the host to port 3000 of the container. Now, we don't need the volume mapping. Good. Next, we're going to get rid of the web tests service. Now for our API, we're going to keep the build property. I'm going to keep the port mapping as well. Next, we have our environment variable. This is totally fine, but we don't need this volume either. Good. Now, our database service is in a good shape. We don't need to make any changes here, but I want to add an extra property to each of these services, and that is our restart policy. So we set restart. The default value is no. So that means if this container crashes, it's not going to be restarted. Our application will be unavailable. So then we have to connect with our server using SSH and manually restart the container. We don't want to use this. We want to use one of the other possible values. Earlier, we talked about the compose file format. So if you Google compose file format, you can find this page. Now over here, we can see version 3 of compose files. Here we can see all the valid properties and their values. We're going to look at restart. So where is it? It's right here. So here are all the possible values. We have no, always, on failure, and unless stopped. Always will always restart the container. On failure will only restart it if the container crashes. And unless stopped is kind of similar to always. The difference is that it will only restart the container if we manually stop it. So I'm going to change this to unless stopped. Now I want to use the same restart policy for the other services. Good. So now we have a compose file for our production environment. Similarly, we could create a compose file for our test and staging environments. So here are the images I have on this machine. Now look at our web image. Look at the size of this image. It's 300 megabytes. In this lesson, I'm going to show you a cool technique to reduce this image size beyond your imagination. First, I have to give you a bit of background about React. So back to our project. Let's go to the front-end folder and open up package.json. So here in the script section, we have a bunch of commands. You have seen start and test so far, but we also have the build command for creating optimized assets for production. So we can go to our front-end directory and run npm run build. This is going to create optimized assets for production. Now, as you can see here, all these assets are stored in the build folder. Now, what if you don't use React? Well, these days, a lot of frameworks have the same concept. They have a tool for creating optimized assets for production. How you use that tool is probably different, but that is irrelevant. So back to our project, here in the front-end folder, now we have this build folder that contains all the assets we need for deploying this application. So we can put these assets inside the web server and serve them. Now, let's see how we can create an optimized image for this front-end application. So let's look at our Docker file. What are we doing here? We are starting from a node image so we get access to NPM for installing these dependencies. But what if we already have these dependencies? Then we don't need NPM. We don't need node. All we have to do is copy these files onto a web server. Okay? So this is where we need to create a separate Docker file for production, because the changes we're going to make only make sense in our production environment, not for development. So back to our project, I'm going to copy this file, paste it, and then rename it to dockerfile.prod. And of course, we could call this anything. This is just a convention. Now, in this file, first, I want to get rid of all these white spaces because I want to restructure this code in a slightly different way. So on the top, we're starting from node. We're going to add an additional keyword here as to give this stage a label. We can call this anything like build stage. So in a Docker file, we can have multiple stages. We can have a build stage and a production stage. We can also add a comment here to make our code more readable, saying step 1, build stage. Now, while building this application, we don't need this user. This is only used for serving it, right? So I'm going to cut these 2 lines from here and move them down below. We'll get back to them in a second. So we create our application directory, copy all the files, install the dependencies, copy the other files. Now, we don't need to expose a port here. Again, this is used for running the application. So I'm going to cut this line and move it here. Now, instead of npm start, we're going to run npm build, because in the build stage, we just want to build our application. Also, we're going to replace the command instruction with the run instruction, because as I told you before, we can have a single command instruction in a Docker file. And this is used for specifying a default command when our container starts. So let's get rid of this. We're going to use run, npm run, build. So at the end of this stage, our application is built. Now we're going to start the second stage. How? Well, we're going to add another from statement, but this time we're not going to start from node, because for our production or for running our application more accurately, we don't need node. We just need a web server. There are many web servers out there. We have Nginx, Apache, IIS for Microsoft, and so on. In this lesson, I'm going to use Nginx because it's a very popular and fast web server. Now, Nginx has different tags. I'm going to use 1.12-Alpine. So this is Nginx 1.12 based on Alpine Linux, super small. Now, if we want, we can give the statement a label as well. So we can call this production stage. We only need this if we're going to refer to this later in this file. We're not going to do that, so I'm going to delete it. So in the second step, which we can specify here using a comment, we can say step 2. This is for production. We're going to start from a web server image, which is far smaller. Then we create our user. Now we're going to copy our files from the build stage. So here we add an option called from. And this is where we reference our build stage. That is why we gave it a label up here. Okay. So we're going to go to our build stage and copy all the files from /app/build to /usr/share/nginx/html. Now, this path you see here is a standard path for serving files using Nginx. You can find this in Nginx documentation on Docker Hub. Now, instead of exposing port 3000, we can expose port 80, which is the default port for web traffic. Now, finally, we can specify a default command or an entry point. In this case, I'm going to use an entry point because every time we start this image, I want this command to be executed. There are no exceptions. So we're going to run nginx and give it a couple of arguments. The first one is -g. The second one is daemon off with a semicolon at the end. Now, once again, you can find these arguments in the documentation of Nginx. There is nothing magical here. So now that we have a Docker file for production, let's build an image using this Docker file. So here in our front-end directory, we're going to run docker build -t. I'm going to call this image vidly_web_opt, meaning optimized. Now we need to specify our Docker file. So -f dockerfile.prod, and then we use a period to specify the build context. All right, our build is ready. So let's look at our images. Take a look. Here's our new image. Look at the size of this image. It's only 16 megabytes. It's a huge improvement. So when deploying this application, instead of transferring a 300 megabyte image, we transfer a 16 megabyte image. Now there's one more step left. So in our front-end directory, we have two Docker files, one for development, the other for production. Now, here we have two compose files as well. We have to go to our production compose file and tell this compose file that we want to use the production Docker file in the front-end directory. So we're going to expand this build property and give it two sub-properties. One of them is context, which we set to the front-end directory. The other is Docker file. So what we had earlier was the shorthand syntax. This is the longhand syntax. Here we're going to type our Docker file name, dockerfile.prod, and we're almost done. Now we should also change the port mapping because now in our production Docker file, we're exposing port 80, not port 3000, right? Okay, good. Now let's verify it's working before moving on to the next step. So back to the terminal, let's get out of the front-end directory. We're going to run docker compose build, but first we have to specify our compose file, docker-compose.prod.yml, like this. Let's go. Good. The build was super fast because everything was in the cache. So let's look at our images one more time. So here's our new web image. Look at its size, 16 megabytes. Beautiful. So now with this amazing optimization, we are ready for deploying our application. And that's what we're going to do next. All right, now the fun part. We're going to deploy this application. First, we're going to bring up the list of our Docker machines. So we have this Vidly machine on DigitalOcean. Now this Docker machine has another command called env for seeing the environment variables that we need to set to talk to this Vidly machine. So take a look. Here are a bunch of environment variables. Now we're not going to manually set these one by one. Instead, we're going to execute this last command. So let's see what's going on here. We're using the eval command on Linux and giving it this argument. You have seen this syntax before, right? So if you have a $sign and a pair of parentheses, whatever is inside the parentheses will be evaluated first and then passed as an argument to this eval command. So inside the parentheses, we're getting all the environment variables to talk to this machine. Now we pass all of those to eval and eval will execute them. So let's copy this line and paste it. Good. Now in the past, we had another command called activate. So we could activate the machine. I don't know why they removed this. This was much easier to work with. But anyway, so now that these environment variables are set, any commands that we type here will be sent to the Docker engine on this Vidly machine. So our Docker client, this Docker client here, will be talking to the Docker engine on this machine. Take a look. So Docker images, look, it's getting a little bit slower because the command is going over the network. So on this machine, we don't have any images. Now, here in the project directory, to deploy our application, all we have to do is run docker compose up. As simple as that. So docker compose up. Now we want to supply our production compose file. So docker compose.prod.yml. And I'm also going to use the detach mode. I made a mistake. I should have put -d at the end. So let's bring up the last command. So up -d. All right, good. So now it's creating this network, this volume. It's trying to build an image for our backend, I believe. But here we might get a permission error. Let's see if it happens or not. All right, we got a permission error saying missing write access to the app directory. To understand why we're getting this error, let's go back to one of our Docker files. So this is the Docker file for our backend project. Now look at this instruction, work there. In the older versions of Docker, this instruction didn't respect the user instruction. So even though we set the user here, work there created this directory using the root user. And the root user is the only user who can write to this directory. Now this issue is fixed in the latest version of Docker because the latest version of Docker uses a different build tool called the build kit. If you have noticed, when we build images locally, our build output is different from what you see here. This is the old build tool. The new build tool, which is called the build kit, gives us colorized output. So some of the lines are blue. You have noticed that, right? So the reason we're experiencing this problem here is because on this VPS, we're using an older Docker engine. And this is a temporary problem with DigitalOcean. Hopefully you will not encounter this in the future. So you can install the latest version of Docker engine and everything will work magically. So what should we do here? Well, we have to go back to our Docker file, and instead of relying on the work there instruction to create this directory for us, we have to create this directory using the root user and change its owner to the app user. So before we set the user, we have to run mkdir/app, and using this command, we can change the owner of this directory. So we're going to set the owner user to app and the owner group to app as well. And here's the directory. Okay. So we create this directory and change its owner to app. Then we set the current user to the app user and everything else is fine. So with this change, let's bring up our application one more time and see if we encounter any other issues. So back to the terminal, we're going to run Docker compose. Then we're going to give it our production YAML file. We're going to bring our application up in detached mode, and we want to use the build option so our images are rebuilt. Okay, our application is up. So let's see if we can access it in our browser. First, we need to find the IP of our server. We can go to DigitalOcean's control panel, or we can run Docker machine ls. So here's the IP address of our web server. So let's copy this. Now, back to our browser, let's go to this address. Nothing is here. What is going on? That's a great opportunity for troubleshooting. So our front-end application is not up, but what about our backend application? Our backend application is available on port 3001/API. Okay, so our API is running. We can also go to API/movies. So all movies are fetched from our database. That part of the application is working perfectly fine. The only problem is in the front end. So back to the terminal, let's look at our running containers. Okay, so here's the web container running Nginx. Now, if you look at the status column, you can see that this container is restarting. Let me resize my window to show you this message. So, okay, it looks really ugly, but I will do my best. So here is the web container, okay? And you can see that this container is constantly restarting. That's because of the restart policy that we applied. So something is wrong in this container. It keeps crashing and restarting. So what is the next thing we need to do? We need to look at the logs. So let me resize this one more time. Good. So let's bring up the container list again. All right. We need the ID of this container to look at its logs. So Docker logs, and here's the container. Good. So take a look. There's so much going on here. All these repetitive messages are saying the same thing. We have a permission problem. And here we're getting a warning saying the user directive makes sense only if the master process runs with the super user privileges. The reason we're encountering this issue is because we're running Nginx with a non-root user. So back to our production Docker file in our front-end project. Look, this is where we're creating a custom non-root user. Now, we can definitely run Nginx with a non-root user, but setting it up involves a bit of configuration and some Linux work. It really goes outside the scope of this course. If you're interested, you can read the documentation of Nginx on Docker Hub. So to go forward, I'm going to remove these two lines and run Nginx using the root user. Of course, as I told you before, this is not the right way to do this, but I don't want us to get distracted from what we are doing. So now we have to go back to the terminal and redeploy our application. So Docker compose -f Docker compose.prod.yaml. We're going to bring the application up and use the build switch to rebuild each image. Okay, it's going to take a while, so I'll be right back. All right, our application is up. Let's verify that all containers are running. Great. So now if you look at the status column, you can see that the web container is running. Great. So back to the browser. All right, we can see the homepage of our application, but we cannot fetch the movies. So we need to troubleshoot one more time. Look, I deliberately included these issues in this lesson so you learn troubleshooting skills. I could have executed these steps in a way that you could never see these and everything looked so clean and polished. So how do we troubleshoot this? We're going to bring up Chrome DevTools and look at the requests sent to our API. So here's Chrome DevTools. In the Network tab, we select SHR to look at our API requests. Then we refresh by pressing Command and R on Mac or Control and R on Windows. Okay, here's the bad boy. Take a look. Look at the URL of this request. It's going to localhost port 3001. This is only for development. Our front-end application running on the web shouldn't send a request to localhost. It doesn't make sense. So back to our project. Let's go to the front-end folder, source, services, and API.js. This is where we have all the code for talking to our API. So look at this line of code. We are saying, if this environment variable is set, use it. Otherwise, use localhost port 3001/API as the default value. So what we need to do now is to set this environment variable in our production Docker file. So we're going to go to dockerfile.prod for frontend. Now, in the build step, this is where we need to set the environment variable, because in React, environment variables are processed during the build stage. So the build tool that comes with React reads all these environment variables and hard codes them in the final code. Okay. So before running the build, we can say environment. Here's the key. We're going to set this to the IP address of our server. So let's run Docker machine ls. All right. Here's the IP of our web server. We're going to grab that. First, we'll start with HTTP. We add the IP. Now the port is 3001. And here we should also add /API. So save the changes. Now we need to redeploy. So here's our last compose command. Again, we're using the build option, so our images are rebuilt. Let's go with that. All right, perfecto. So let's go back to the browser, refresh, and here are all the movies. Great. So our application is up and running on our internet. So let's quickly recap. If we put aside all the little issues that we encountered in this lesson, deploying Docker applications is actually very easy. First, we have to activate a Docker machine. So we run Docker machine ls. Let's say we want to deploy to this machine. This could be our production machine. We could have another Docker machine for our test environment. We could have another one for our staging environment and so on. Once we know where we want to deploy this application to, we run Docker machine env with the machine name. So we get the command that we need for activating that machine. We execute this command. Good. Now this machine is active. So any commands that we execute using this Docker client will be sent to the Docker engine on the target machine. So here we can bring up our application using Docker Compose up. As simple as that. And if you think this is too tedious and you have to execute multiple commands, you can simply put these commands in a shell script like deploy.sh. And every time you want to deploy, you just run that script. So in that script, you're going to activate your production machine and then run Docker Compose up with the right options. Earlier in the course, I told you that you should properly tag your images before deploying them to various environments. So in this window, we're still talking to our production machine. Let's run Docker PS. Okay, look, on this machine, we have this image called Vidly_web, but we don't know what version of our application is included in this image. This is the problem I was talking about. So if we encounter inconsistencies amongst different environments, let's say our application works in a certain way in the staging environment, but not the same way in production. We don't know what version each environment is running. So we want to properly tag our images. How? Back to our production compose file, look at the definition of the web service. Here we have the build instructions, but in addition to build, we can also add the image property to tag this image. So we can say this image is going to be called Vidly_web : let's say this is version 1. Now, similarly, we can add the image property to our API service and say, once this is built, it should be called Vidly API version 1. Save the changes. Now we're going to redeploy. So let's run Docker Compose again using the build option because we want to rebuild our images, right? Let's go ahead with that. All right, our application is redeployed. So let's run Docker PS one more time. Great. Now we can clearly see in production, we're running Vidly version 1. Now tomorrow, if we decide to deploy a new version, we have to go back to our Compose file and manually update this and then redeploy. This is not ideal. That's why we use continuous integration and deployment tools. Using continuous integration and deployment tools, we can automate our deployment process. So we can configure our tool to check out the latest version of our code from our GitHub repository. Then it will build our image and tag it according to the latest build number. Or we can have our tool tag our images based on the latest commit. This way we can easily trace what version we are running in each environment. So instead of an arbitrary number here, we will have our git commit ID or the build number. That really goes outside the scope of this course and is something you need to learn on your own. So that brings us to the end of this course. I hope you have learned a lot and I'm going to see you in my other courses. If you enjoyed this course, please support me by telling others about it. I really appreciate your support. Once again, thank you and I wish you the best.